So these notes here, greatest common factors, it ties into some of the skills that we were doing in section 1, so it's kind of a nice extension. There's a little bit, tiny bit of new stuff in the application, but it's essentially the skills that we did before. First thing I want to talk about is like, when we're talking about like a factor or a factors, what is that? And I put this in the section 1 notes. You can skip it if you want to, but if you have two numbers that you're multiplying, those are both called factors. So you have a factor times a factor equals a product. So for example, you could have like 2 times 3 equals 6. 2 and 3 are going to be factors of 6. And you could also say like 1 times 6. 1 and 6 are also going to be factors of 6. So that's kind of what we're talking about when we say greatest common factor. The point of this section is the book, myself, we're going to give you like 2 numbers or 3 numbers. So maybe like a 6 and a 24, or a 6 and, 32. And we're going to say, what are the biggest common factors? So of all the numbers that can go into 6, 1, 2, 3, and 6, and all the numbers that could go into 30, which one of those numbers is going to be biggest? That's kind of where we're going. So if you wanted to, you could say then the greatest common factor. What are we really talking about when we do that? That is the largest number that 2 or more numbers can be evenly divided by. So the greatest common factor is the largest number that 2 or more numbers can be divided by, or divided evenly by. So that's really the point of this section, is how do we take 2 numbers or 3 numbers and figure out what is that biggest common factor? What's the biggest number you could divide them both by? There's 2 ways to do it. So 2 ways. I think in most situations the first way is going to be harder. So I would probably avoid this first way, especially if the numbers are large. But one way is to get all the factors. So get all factors of both numbers. Sure. I'm going to assume that we're just trying to find the greatest common factor of 2 here. It makes the step 1 look a little bit more clear. But get all the factors of both numbers, or all the factors of all the numbers. Then identify the largest one they have in common. The largest one they have in common. I think some people in the notes for section 1 refer to that as like the rainbow method. Go through and list out all the different ones. And then just look at those 2 different sets of factors. What's the biggest one? That's going to be easiest if you have like smaller numbers maybe, or really nice numbers. But once you especially get into like 3-digit numbers, that's probably going to be really ugly. The way I prefer, so I'm going to put a star by it, I really like number 2, is you do a factor tree. So that's what we were doing in the last section. Then once you've done your factor tree, you multiply the prime numbers, because factor trees give us all the prime numbers. You're breaking a composite number up into prime numbers. Multiply the prime numbers they have in common. Sure. What I like about the second one is I'm less likely to miss one. I've had it before, and I've seen students that as they go through in step number 1, or method number 1, they go through and they come up with all the factors. Well, if you miss one pair of factors, then you get the wrong answer, even though you did tons of work. The factor tree for me feels a little bit more straightforward, less likely to miss one thing and get it wrong. So I'll do a couple examples of the factor tree one. So find the GCF, greatest common factor, of 24 and 40. Let's find the greatest common factor of 24 and 40. For me, I like pulling out 2's as long as I can. Some people for 24, they'd rather do like 6 times 4 and go from there, but I often will just start with a 2. And I can say this 24 is going to be 2 and 12. And then if I break that up, I have 2 and 6. And then I could break my 6 up into 2 and 3. So now as far as my prime factors there, I have 2 times 2 times 2 times 3. Yes for number 24? Or 2 to the third times 3 is how we normally write it. But we're not trying to figure out the prime factors. We're trying to figure out, greatest common factor. So I'm just going to leave my numbers that way, 2, 2, 2, and 3. I do the same thing with 40. Divide 40 by 2, I get 20. Divide 20 by 2, I get 10. And then with the 10, I could say 2 and 5. And I'm going to circle those just to make them show up a little bit more. Now, once we have that, so that's what we were doing in the last section, this new stuff now, you just multiply together the ones that they have in common. So to the degree they both have 1, 2, so I have a 2. Okay, now they both have a second 2, so I'm going to multiply a second 2. They both have a third 2, so I'm going to multiply a third 2. Now my 24 had a 3, my 40 doesn't. My 40 has a 5, my 24 doesn't. So the only ones they have in common are going to be these 3 2's, right? So 2 times 2 times 2 is 8. So that would be the greatest common factor of 24 and 40. Yeah, it's not bad. I don't think it's bad. With the next one then, let me do a different example. And this time I'm going to throw 3 numbers in there. So find the GCF of 120, 216, and 168. So even though there's 3 numbers now, we just have to do 3 of the factor trees, and then once we're done, look at, what prime numbers are in all 3 of those factor trees. And so I'll start with the 120. So 120, I could break that up into 2 and 60. Nice job, Mary. Next we could say 2 and 30. Then 2 and... Could do 3 and 10 if you wanted to. I'm going to stick with 2 and 15. But 3 and 10 is totally fine. 3 and 5. Sorry, I'm a creature of habit. Okay, so I have my prime factors here. So that's my 120. My next one is my 216. So maybe let's go with orange. 216. It's supposed to be orange. 216. 2 and... Want to know how I do that one in my head? If I were to cut it right there, I could divide my 2 in the 100 spots by 2, right? And I get a 1. So I have a 1 in the 100 spot. Half of 16 is going to be 8, so I have 108. So that's one way to do it in your head. If you can do it in your head, you don't have to grab a calculator. It'll be faster. 9 times 11? No.
9 times 12.
Actually, it is 9 times 11. It can't be 9 times 11. Oh, yeah, 99. Bummer. So you could say 9 times 12. Should we do the 9 times 12? Should I do a 2 and 54 or 9 and 12?
9 and 12. 9 and 12 is easy. No.
So if we do 9 and 12, if you want to, I'd do 2 and 54, it's fine. So then we have 3 and 3, and 4 and 3, 2 and 2. So we have those numbers there for our prime factors. Still good? Then our last one, we switch back to the green, 168. 2 and half of 16 is 8, so 8 in the 10 spot. Half of 8 is
4.
So 84.
And 2.
And then 2 and 42. 2 and
6 and 7.
I could do 6 and 7, but 2 and 21.
3 and 7.
3 and 7. See those there? 3 and 7. All right, so now we have all of our prime factors for this one.
Is that 3?
It's supposed to be a 3. I missed in the middle. So now if we so there's 3 2s in all of them. So I have 1 2 in all of them. So a 2, a second 2, 2, a third 2 in all of them. What else is in all of them?
3.
We have 1 3, 1 3, 1 3. So 2 times 2 times 2 times 3 is 24. So 24 would be the greatest common factor. The other way that you could do it, so I'll maybe do just quick one example of method number 1, and then we'll move on from there. So if we were to say, so maybe example 3, if you wanted to find the GCF of, I guess if we do those first ones again, so you could skip this. If you're just going to do the factor tree, feel free to skip this. But if you wanted to show your work for doing it the other way, you could say, all right, 24, that's going to be 1 and 24, and 2 and 12, 3 and 8, 4 and 6. Yes? Then you could do the same for 40. Drop down a little bit. So if I have 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, and 6 and 7 don't work. And then you just kind of go through and say, all right, the other one doesn't have 40, the other one doesn't have 24, the other one doesn't have 20, 12, 10. All right, so 8 then has to be the final answer. So you could go through and do it that way. That was that first way of doing it. But if you're starting to deal with numbers like 168 and 120 and 216, this is just going to be way more work to come up with all the factors.